The USA has mounted it, and as I know, maybe China also have it also. Maybe.
You have it?
What?
You have like can
Maybe. I'm not sure. I'm not sure. This is secret. It's a secret. But it's
Okay.
really interesting. It will be the future. It will be the
Yeah,
future.
really. It is very amazing.
Okay, inductor. The inductor defined by the psi and I. It also have the linear and nonlinear. This means linear, nonlinear. And we use this symbol to express the definition. This linear inductor is psi L over I. For the linear inductor, it will be straight line across 0. We call this the self-inductor coefficient. Inductance coefficient. Self-inductance, this L, because we have also mutual inductance. Mutual inductance. And the voltage and the current relation, this is voltage current relation. U equal to L dt. This U and I relation. U I relation. And this for the common motor inductor. The motor inductor will change with time. It will be cos omega t. For this expression, it will be a linear time variant. Component. Linear time variant component. For a nonlinear inductor, this will be the symbol. It also have 4 types: current control, magnetic control, the monotonous, and the multiple value. This is a common inductor. Psi I relation. Okay, the emphasis memorator. We use this symbol to express memorator. If component is psi and Q relation, psi-Q relation, we call this component memorator. Rm, the memorator defined by the psi and Q relation. F psi Q equal to 0. F psi Q equal to 0. We call this memorator. The character of memorator assume is a Q control, charge control, psi equal to FQ. And if we differential time t in two sides, d dt, it will be like this form. So d psi dt will equal to voltage. dfq dt will equal to dfq dq multiple dq dt. And the dq dt is current. This is current. So it will be this. We use the MQ to express. So the voltage and the current relation is voltage equal to MQ multiple LT. And we know the MQ is ohm, because this voltage, this current, so the unit should be ohm. Be resist ohm. And it contains the charge Q. We know the charge Q is the integration of the current in the integration current. So this means the UT will equal to the I multiple MQ. MQ will be an integrate Fi function. Integration minus t minus 2t. So we call this if the Fm, if this function is linear, for example, the psi equal to 5q, the MQ, this position, for this part, psi equal to 5q, d psi dt equal to d5q dq multiple dq dt, and this will be 5, this will be I, this will be u, so it will be a common resistor. So if fm is a linear function, this linear function, the m will be constant, so it will be a common resistor. If this function is nonlinear function, so this part will contain q. We call this mem resistor. Why is mem resistor means? Because it's an integration of current, so we can treat it as it can remember the current. So this word comes from memory plus resistor. Memory resistor. So in China we call it memory resistor. So the English name is memory resistor, because the UI relation can remember the history of the I. So we call it memory resistor. In 1971, the Professor Cai of UC Berkeley. The Professor Cai come from the Taiwan. It's Chinese Taiwan. It worked in the UC Berkeley. It raised the memory concept, but no one has really found this element. It's just from the UI relation. UI, the Q, posi. Sorry, this posi. Q. UI is resistor, this capacitor, and this inductor. And then he think why the posi and Q can't form a component. So he raised the memory concept. But no one really found this component. Not really found. But in the 2008, the Nature announced they found memory resistor. It comes from HP lab designed actual memory by nanotechnology. And at the 2013, the HP worked with Hynix, released a memory-based memory. It means computer memory based on the memory resistor. And in the 2015, the Tsinghua University and the Stanford use memory resistor form a neural network to recognize the human face. This is Professor Cai. Working in UC Berkeley, and this HP engineer in 2008, they print the work in Nature, and I'm so lucky to have a photo with Professor Cai, and I take this photo at 2017. Professor Cai now is around maybe it's around age 83, maybe 83. Professor Cai. He read the concept of the memory resistor. Okay, this is a paper in the Nature. Sorry, you can find this paper. And if you have enough interesting, you can search on the Nature website, nature.com. In this website, you just search this, so you can find the paper, and you can also search my name. You can find my paper also. Okay, I'm introducing myself. I'm sorry. Okay, for the independent source, we have discussed only 4 kinds of RLCM, 4 kinds of basic components. the independent source is not a basic component. The independent source for the voltage source, UAB equal to US, we can treat it as a US plus 0 multiple I. So this is a nonlinear resistor. Nonlinear resistor. We can also write in the US plus 0 multiple Q. This will be a nonlinear capacitor. So the voltage source, we can treat it as a resistor or a capacitor. And for the current source, IB equal to IS plus 0 multiple U, we can treat it as a nonlinear resistor. This is voltage control. Voltage control. We can also write IS plus 0 multiple psi. This is a nonlinear inductor. So maybe you will ask why we write as IS plus 0 multiple Q. Why not write as this? Because Q and I is differential relation. I equal to dQ, dt. It can't form a component. So the current source is a resistor or an inductor. The voltage source is a nonlinear resistor or nonlinear capacitor. Pay attention, this is a difference with the underground course. Different course. This is source. This is current source. This is voltage source. For a basic component, is linear or nonlinear, time invariant, time invariant. For this, Q equal to Cu. The C is constant, is linear and time invariant. So this means linear time invariant. Q equal to Cu multiple U. This Cu means C is a function of U. C is a function of U. So for this component, is nonlinear, but time invariant. For the Q equal to Ct multiple U, the C is a function of T. Maybe like this example. For this component, it will be linear component, but time invariant. Linear component, linear time invariant. And if the C is a function of U and T, for example, like this, it will be nonlinear and time invariant. So the basic idea to judge a component is linear, nonlinear, or time invariant. You can judge R, L, C. If these three components is a function of time t, so it's time invariant, or it's time invariant. Is R, L, C is a function of the U or function of I? We call it nonlinear. This is nonlinear. So it's a function of UI, nonlinear. Function of current, function of time t is a time invariant. So this is the conclusion for this part. Okay, we'll introduce another kind of component, high order component. This is not basic component. So high order means the definition U alpha I beta. Pay attention, this U alpha, this I beta means the differential. Alpha beta means differential. This U alpha means du dt. Alpha order differential. We call this high order component. Alpha minus beta, the absolute value of alpha minus beta is the order of this element. If any one of it are positive, we call the circuit as high order two-terminal element, high order. For the L and C, U equal to L di dt. The C is I equal to C du dt. This is first order. This is first order. If second order or third order, we call this higher order component, higher order element. We use this symbol to express this alpha, beta. This means the order of the U, the order of the I. The order of the component is alpha minus beta. For component, for any component is zero order. For the inductor, the inductor is U equal to L di dt. Or the I equal to 1 over L U integration. So the minus 1 means integration. The 1 means differential. So this is the U is minus 1, I is 0. So for the inductor is first order component. For the capacitor is also first order. For the memorator, this memorator, it's also a zero order. Just minus 1, so it's zero order. For this component, it will be a three order. This voltage order, current order, maybe like this form. For example, du dt, second order, equal to 5 multiple I first order integration 0t, maybe like this. We call this three order component. Pay attention, the U and I can have only one kind of order, and U is alpha order, beta is I is beta order. For example, this is not three order, because this second order, first order, this 0, this 0. For example, for this component, it seems like a three order. This is zero order. This is zero order. This is first order. 0, 0, 1, 0, 0, 1. So it seems like not like a basic component. But if we integrate this function, integrate, we can find this part will be the magnetic chain, and this part will be like this form. So it will be a basic inductor, nonlinear inductor. Okay, we'll introduce two kinds of high order component. The first kind is E element, E component. The definition is the U is high order, not only two, it's high order of the current. Maybe like this, U equal to E mod din order dt. Okay. So call this E element. It is similar to the L element. The L is U equal to L di dt. So the L element is first order, this is high order. We call this E element. So the E element, we can treat it as a generalized of the L element. Generalized. We use this to express E element. Similar to an inductor, but high order. Another D element. The D element definition is the current is high order differential of the voltage. The definition I equal to D multiple du dt. High order difference, high order. This N is high order. This D means coefficient. It is similar to the C component. C I equal to C du dt. This is capacitor. So the D element we can treat as the generalized of the C component. So the L and the E similar. The C and the D similar. This is high order. just first order, high order, first order. And in the sinusoidal steady state cycle, sinusoidal steady state, for example, for this component, this is time domain. If in the sinusoidal, the U phasor will equal to this differential two times, it will j omega square multiple E and multiple I. Sorry. E multiple I square. The j omega square will equal to U square equal to minus square multiple I. So we can treat this as a resistor. Seems like a resistor. And this resistor will change with frequency. So we call this as frequency-based resistor. And if this odd second, if this even, maybe for example for 3, we call this a frequency-based resistor. If this differential order, even, if it's even, for example, E equal to, U equal to E mod di3 order dt, third order. So in the phasor, U phasor equal to E mod, this third order. So j omega, third order, and I phasor. This third order will equal to minus j E omega 3 I. So we can treat it as an inductor or capacitor. So we call this frequency-based, because it will change with 3, it will change with the omega. Frequency-based, the inductor or capacitor. Okay, today is enough. We'll make a conclusion. Today we have discussed the linear, nonlinear, and nonlinear. How to judge linear, nonlinear. This is one content. The second content is we have discussed the RLC component. For this rectangular component, it has 4 types. Canal control, water control, monotonous, or multiple volume. And then we have discussed the memory. This is important. And 3, for the DC source. Pay attention for this, the DC source. The DC source is not a basic component, For DC source, the voltage source US, current source IS, this can treat as a resistor or a capacitor. For current source, we can treat as a resistor or inductor. And then we have discussed the high order component. We discussed 2 kinds, the E component and the D component. The E component similar to the L component. The D component similar to the C component. Is I equal to D mod U high order, T high order. The E component is U equal to E mod I high order, T high order. Okay, today is enough. This is the total content for today's class. Do you have any question? Okay, if no question, I will exit. Okay.
Bye-bye. Thank you.
Okay, no any question? Okay, see you.
Thank you.